Hi, I'm Robin. So we're gonna solve this question number 21, which is from GATE Physics 2013. So, we are not gonna solve. This is a very phenomenological question and a theoretical question. So it's basically from the last part of condensed matter physics, solid state physics, where you study about the superconductors, and there is a BCS theory which talks about the Cooper pairs. And so there are some postulates by this theory after doing all those derivations. If you would have done the advanced condensed matter course, you would have actually derived those formulas, which I'm going to write. So, which are from the BCS theory of superconductors. So there are some points given to you, and you have to find which one is the not the correct statement by this theory, which one is the wrong according to this theory. Okay. So yeah, so first one talks about whether presence of energy gap at the temperature below the critical temperature. That is very true. So in BCS theory, they predict the dependence of the energy gap, which is delta, as a function of T on the critical temperature, right? So you must have studied that ratio of the energy gap at the zero temperature to the value of the critical temperature, which is nothing but 1.764, right? And also you must have studied as a temperature dependence below T less than C. How it is? It is basically, if you go less than T, it is 3.06 kb Tc 1 minus T by Tc. Okay, so yeah, at a current temperature below the critical temperature, use this is right. Okay, second one is different temperature for the isotopes. Okay, so you must have studied something called isotope effect in the um, BCS theory, which is also the experimental observation for a given superconducting material. And the critical temperature is inversely proportional to the square root of the isotope mass, right? So this Tc is inversely proportional to the mass of the isotope. So isotope are the two materials with different masses. So yeah, there is an isotope effect that you see in the superconductors. So yeah, this is also right. The next one, quantization of magnetic flux in the superconducting ring in the unit of h bar by E. No, that's wrong. It is in the quanta is h bar by h by 2e, not h by e. So this is the wrong one. That is fine. But let's also discuss the last one, which must be right, is the presence of Meissner effect. Yeah, that's the main part. So BCS theory predicts the Meissner effect, which is basically expulsion of the magnetic field from the superconductor. And there is a quantity which at which it decays in the superconductor, that small length scale, which is called penetration depth, right? So basically to the extent at which the screening currents flow below the metal surface. Okay, and that has a variation with the temperature as well. So this is also right. So the clearly the wrong option was C. So yeah, this was related to some basics of the superconductors, yeah, that you should know. Thank you.